Okay, sensible heat. Key term here. So sensible heat is when if heat is added or removed from a substance and the temperature changes, that is what's called sensible heat. So and that you can measure the change in temperature. So if you put an iron rod over a flame and you put a thermometer on that iron rod and that thermometer starts to increase in temperature, we are now absorbing sensible heat. And remember, heat's molecules in motion. Latent heat, that is when heat is added or removed and it changes the state of the substance. And in our case, that's the refrigerant. So when there's a change of state, all of that heat energy that is added or removed is absorbed and used to change the state of the refrigerant. And if you put a thermometer in there while you're adding heat and it's changing state, the temperature doesn't rise. And we'll go through an example of using water here with sensible and latent heat before we get on to the refrigeration cycle. Remember, changing state in our field is from liquid to vapor. And when refrigerant changes from liquid to vapor, it requires a tremendous amount of heat energy to make that change. And that's why refrigeration works. And then the other change of state in our refrigeration cycle is vapor to liquid. And that releases all of the heat, all this heat that's required to change the state from liquid to vapor. It's released when the refrigerant condenses back down from vapor to liquid. All right, so change of state is where the refrigeration process happens. Okay, let's take a look at this diagram. This is a diagram out of our textbook, and it starts down here at, with minus 17 degree ice. We're not going to talk about the ice raising temperature and melting. We're going to talk about 32 degree water, and we're going to start right here at this part of the graph. So we take 32 degree water, and this is our BTU content here. So as we begin to add heat, the temperature begins to rise of our water from 32 to 50 to 60 to 100. This is sensible heat. So it raises the temperature up to 212 degrees, which is the boiling point of water. And as you can see in this diagram, it only takes 180 BTU of sensible heat to raise the temperature of 32 degree water to 212 degrees. And this is 1 pound of water, by the way, not 5 gallons of water. All right, so that is our sensible heat. So again, as the heat is added and the temperature rises, and you can measure it with a thermometer up to 212 degrees, this is our sensible heat range. As soon as we hit 212 degrees, the water starts to boil. That's our change of state that's happening with the water. Now remember, the change of state, as we add heat, the temperature can't be measured and doesn't rise. So we plateau up here at 212 degrees, and this water continues to boil, and it changes state and changes state and changes state until it is completely converted into vapor. So when it's changing state, it's going from liquid to vapor. And as you can see, it takes almost 100 times more, a little bit less than 100 times more heat energy to boil that and change the state of that water than it does to raise the temperature. And that's why we have, we're able to remove a lot of heat out of the space that we need to when we're running our refrigeration system. Okay, so we get back up here. We've changed state, and now all of the water has changed state from liquid to vapor. We're at this point right here, and we are at 100% vapor. And if we continue to add heat, then the temperature again starts to rise, because that vapor, it can no longer change state. There's no more liquid to boil off. So this is again back in the sensible heat range. And when we do the refrigeration cycle, we're going to look at a little bit of sensible heat on this end of the scale. Then we're going to take a look at all of this latent heat that happens on this scale. And then we're going to take a look at just a little bit of sensible heat on the other end. And that's why it's very important to understand sensible and latent heat and changing of state. All right, I'm going to take a quick break here, see if there's any questions. I cannot see the question box while I'm doing the whiteboard, so I don't want to leave anybody hanging so far. So let's see if we have any questions, and then we'll pop back. Okay, so far so good. Let's move on.